Bismillahirrahmanirrahim. Hope is the only bee that makes honey without flowers. Today, my topic of presentation is two-sample hypothesis testing under the supervision of Professor Dr. Saira Afzal. In this presentation, I shall be covering the points of definition of hypothesis, types of hypothesis, a brief overview of steps in hypothesis testing, t-test and its types, two-sample t-test, two-sample z-test, and multiple choice question session at the end. At the end of the presentation, participants will be able to describe the basic steps of hypothesis testing using two-sample t-test and z-test, along with assumptions of both tests. Now, in yesterday's presentation, hypothesis and the first few parts of my presentation were explained. I will give a brief overview of a revision session. What is a hypothesis? Hypothesis, plural hypothesis, is a proposed explanation of a phenomenon. For a hypothesis to be a scientific hypothesis, the scientific methods requires that one can test it. Scientists generally base scientific hypotheses on previous observations that cannot satisfactorily be explained with available scientific theories. For example, a study designed to look at the relationship between sleep deprivation and test performance might have a hypothesis that states, this study is designed to assess the hypothesis that sleep-deprived people will perform worse on our test than individuals who are not sleep-deprived. And a hypothesis should always explain what you expect to happen, be clear and understandable, be testable, be measurable, and contain an independent and a dependent variable. There are two types of hypotheses in research, a null hypothesis and an alternate hypothesis. Null hypothesis, it is a hypothesis where variations are not at all expected. For example, there is no significant relationship between compensation policy and employee satisfaction. Alternate hypothesis, so variations are expected. For instance, there is a significant relationship between a company's compensation policies and employee satisfaction. So the steps of conducting while doing hypothesis testing, as explained yesterday, were that first of all, we state the hypothesis, then we identify the test statistic and its probability distribution. Specify the significance level, state the decision rule, collect the data and perform the calculations, make the statistical decision, and make economic or investment decisions. Two-tailed z-test, for example, the null hypothesis at 5% significance level. Null hypothesis is mu is equal to mu naught for the sample. Alternate hypothesis, mu is not equal to mu naught. And when we plot the normal distribution curve, we see that we have two rejection areas in two-tailed test and the one-tailed z-test at 5% significance level. We have rejection area in which, in this case, if the hypothesis is null hypothesis, states that mu is less than equal to mu naught, and alternate hypothesis states that mu is greater than mu naught. So in this case, it's a one-tailed z-test at 5% significance level, and we have the rejection area on the right. Now, a little about t-test. T-test is a type of inferential statistic used to determine if there is a significant difference between the means of two groups, which may be related in certain features. The t-test is one of many tests used for hypothesis testing in statistics. Three types were explained. An independent sample t-test compares the means of two groups. I shall be explaining this type in detail with example. A paired sample t-test compares means from the same group at different times apart, say 1 year apart. One sample t-test test the mean of single group against a known mean that has been explained earlier yesterday. What is a two-sample t-test? A two-sample t-test also known as an independent samples t-test, is a method used to test whether the unknown population means of two groups are equal or not. The formula in this case we use are t is equal to x bar 1 minus x bar 2 divided by under root squares of 1 over n plus 1, the sample 1, n plus 1 by n plus 2 for the total number of sample 2. So what are the assumptions for the two sample t-test? The assumptions for the two sample t-test are: the data are continuous, not discrete. The data follow the normal probability distribution. The variance of the two population are equal. If not, the absent whilst unequal variance test is used. The two samples are independent. There is no relationship between the individuals in one sample as compared to the other, as there is in the pair t-test, where the observations are taken from the individuals of the same sample at two different times, a gap apart. Both samples are randomly selected and have simple random samples from their representative population. Each individual in the population has an equal probability of being selected in the sample. So in an example, teaching and reading example, Damien believes that new reading activities in the classroom will help elementary school pupils improve their reading ability. He arranged for the third grade class of 21 students to follow these activities for 8 weeks. A control of classroom 23 third grade follows the same curriculum without activities. And at the end of 8 weeks, all the student gives the degree of reading power test, DRP test, which measures the aspects of reading ability that the treatment is designed to improve. And the significance level was 5% test if Damien's new activity for the treatment group improved the student's reading ability. So this was the results. The scores from the treatment group and the control group. The treatment group for students under the new reading activity and the control group for students without the reading activity. When a box plot was plotted, the distribution of the students under the new reading activity was slightly skewed to left. So in this example, we shall proceed with caution. And on the right, the box plot shows that the distribution is approximately normal. So we shall continue with caution, as the students under new reading activity had data slightly skewed to left. So the mean for treatment group was 51.48 and the mean for the second group was 41.4. Standard S was 11, S was 17.15 and N was 21 and N was 23. Now for the steps. Mu1 is unknown and mu2 is mu1 is for sample 1 and mu2 is for sample 2. The null hypothesis in this case is that mu1 is equal to mu2. An alternate hypothesis can be mu1 is greater than mu2, mu1 is less than mu2, and mu1 is equal to mu2. Step 2. Now we will satisfy the assumptions or the requirements for the tests. Are both samples normally distributed? Second step is, are both samples randomly selected, and are both samples n greater than 10 times the sample size? In step 3, the value of t is calculated by using the formula. In step 4, the distribution of the rejection areas are represented according to the alternate hypothesis. In step 5, we make a decision whether to reject the null hypothesis or to fail to reject null hypothesis. So in step 1, mu1 was the mean for the test scores for the treatment group, and mu2 was the mean DRP test scores for the control group. In this case, the null hypothesis shall be mu1 is equal to mu2. Like there is no difference between the between the test scores of both the groups. But in alternate hypothesis, mu1 is greater than mu2, since Damien was expecting that the test scores of the reading ability of the treatment group would be increased and test scores would be better. In step 2, random selection was not stated, treatment group is slightly skewed, sample is independent, and we shall proceed with caution. In step 3, the sample is taken, the formula, and the values are put, and T comes out to be 2.375, and the P table value comes out to be 0.114, and degree of freedom is 37.84, and alpha is 0.05. Hence, the conditions were not satisfied. And the steps, we conclude that with p-value of 0.114, which is less than 0.05, we have enough evidence to reject null hypothesis, which makes our test significant. Therefore, the new reading activity improves the student reading ability. However, since some of the conditions were not satisfied, we have proceeded with caution. In example 2, the braking distances of 8 Volkswagen GTI and 10 Ford Focuses were tested while traveling at 60 miles per hour at a dry pavement. The results are shown below. Can we conclude that there is a difference in two types with alpha level 0.01? Here the data for GTI and Focuses is given. When values were put, the T value comes out to be minus 3.496. The hypothesis that was set was mu1 is equal to mu2. And the alternate hypothesis was mu1 not equal to mu2, since it was two-tailed. Alpha was 0.01, degree of freedom was 7. And with the value of T and at 1% significance level, there is not enough evidence to conclude that the mean braking distances of the cars are different. The second, I would like to just give a brief overview of paired sample t-test. A paired sample t-test is used to compare two population means when you have two samples in which observation in one sample can be paired with the observations in the other sample. So the main differences between independent sample t-test and paired sample t-test. Independent sample t-test, two samples share some variable of interest in common, but there is no overlap between membership of two groups. However, in paired sample t-test, usually based on group of individuals who experiences both conditions of variable of interest, also called as repeated Meyer design or paired design. So for example, in independent sample t-test, compare the running speed of horses and zebra would be an independent design, as there is no sensible way to pair off each horse with a zebra. While for the paired sample t-test, compare the running speed of horses for a week of eating one type of feed with the same horses for a week on the different type of feed would be a paired design, as you can pair of measurements from the same horse. Now the two sample z-tests. Z-tests for two samples. When we have a large sample and the two normally distributed with independent populations and the population standard deviation is known, then we use the z-test for two samples. The formula given for the z-test is x bar minus x bar 1 minus x bar 2 bracket closed minus mu1 minus mu2 over under root sigma 1 square over n1 plus sigma 2 squared over n2, where x1 and x2 are the means for the two samples. Mu1, mu2 is the hypothesized difference between the population mean. Sigma 1, sigma 2 are the standard deviations for the two populations, and n1 and n2 are the sizes of two samples. Now, what are the assumptions while using the difference between the two means using a z-test? So the sample must be independent of each other. That is, there can be no relationship between the subjects in each sample. The standard deviation of both populations must be known. And if the sample size mostly we apply z-test on large, but if the sample size are less than 30, then population must be normally or approximately normally distributed. Here is a little comparison between z-test and t-test. Z-test, where the population, standard deviation, and standard errors are known, and where the sample size is greater than 30, where the normal curve is the model for sampling distribution for determining the probability of obtaining our result under the null hypothesis. For the t-test, where population, standard deviation, and standard errors are not known and have to be estimated from the sample data, where the t-distribution is a model for sampling distribution for determining probability of our results under the null hypothesis. Now it's time for the MCQs. For MCQ number 1, 11 patients were weighed before and after a diet which was designed to help patients reduce weight. 8 of these patients did lose weight, but 3 patients had a weight increase. To test whether the diet is successful, state the appropriate null and alternate hypothesis in terms of P. The probability that the diet increases weight. That would be the key to synthesize the hypothesis. Which one option must be correct? H0 where P is equal to 0 and H1 P is less than 0. Second option is where null hypothesis P is equal to 0.5 and alternate hypothesis P is less than 0.5. And in third option, P is equal to 0.5, whereas P is not equal to 0.5. And in fourth option, null hypothesis P is equal to 0.5 and P is greater than 0.5. So what will be the best option for this scenario? B would be the answer, because the probability that the diet increases the weight, we are using the increase in weight on average. So the P must be less than 0.05 to be significant. So B is the right answer. The P value in hypothesis testing represents which of the following? Please select the best answers below. The probability of failing to reject the null hypothesis, the probability that the null hypothesis is true given the observed results, the probability that the observed results are statistically significant, the probability of observing results as extreme or more extreme than currently observed given that the null hypothesis is true. No, the answer would be D, that yes, the answer would be D, that probability of observing the results as extreme or more extreme than the currently observed. So we compared the P with that P value with the test statistics. So D is the right answer. In the third example, a sociologist focus on popular culture and media believes that the average number of hours per week spent to social group media is greater for women than for men. For two independent samples, simple random sample of 100 individuals, researcher calculates standard deviation 2.3 hours and 2.5 hours respectively for women and men. If the average number of hours spent using social media for sample of women is 1 hour greater than the sample for the men, what is the conclusion from the hypothesis test, where H0 is mu women minus mu m is equal to 0 and mu women minus mu men is greater than 0. The observed difference in average number of hours spent using social media is not significant. The observed difference in average number of hours spent on social media is significant. Conclusion is not possible. Conclusion is not without knowing the population size. Since it's clearly given that if the average number of hours spent peak for women is 1 hour greater than the sample of the mean, so the observed difference in average number of hours spent on social media is significant. So the right answer would be B. In which of the following cases would an independent sample t-test not be appropriate? Comparing younger and older adults' level of teamwork, comparing the performance of individuals who either consumed caffeine or did not, comparing levels of aggression between one group who expressed high level of excitation and one group who remained calm, comparing the attitudes of Eastern and Western, and comparing students' attitude change between start and the end of their day. E would be the answer, because the remaining options have the comparison of two independent samples, whereas in option E, there is an overlapping between the observations of the study samples like before, between the start and the end of their degree. Hence, E is not appropriate for performing an independent sample t-test. For the 5, where would you look at an independent t-test output in an SPSS to identify whether there was a significant difference between the groups of nodes? The correlation coefficient box, the confidence interval column, the F column, the test for equality of mean section, the descriptive statistics box. In SPSS, whenever you have to see whether there is a significant difference between two groups of knot, in an output sheet, you always look for the t-test for equality of mean section, where you would be clearly seeing a difference. An independent t-test can be used to assess which of the following. It assesses difference between scores obtained on two separate occasions from the same participants. It assesses the difference between two groups of participants. It assesses how many factors there are in a questionnaire, and it assesses goodness to fit. B would be the right answer. It assesses the difference between the two groups of participants. The first one does not imply because it's a paired t-test would be applied. Now, a random sample of 5,000 students were asked whether they prefer a 10-week quarter system or a 15-week semester system. Of these 5,000 students asked, only 500 students responded. The results of this survey can be generalized to the entire student body because the sample was random, can be generalized to the entire student body because the margin of error was 4.5%, should not be generalized to the entire student because the non-response rate was 90%, and should not be generalized to the entire because the margin of error was 4.5%. The answer would be C, as you clearly see that out of 5,000 students, 500 students, only 500 students responded. So the results should not be generalized to the entire study student body because the non-response rate was 90%. A significance test based on a small sample may not produce a statistically significant result. Even true values differ substantially from the null value. This type of results is known as significance level of test, the power of test, a type 1 error, a type 2 error. That would be a type 2 error, like in a small sample, we can face problems and we can have more chances of type 2 errors. What determines how close the computed sample statistics have come to the hypothesized population parameter? The level of significance. The answer is D. The test statistic determines how close the computed sample test has come to the hypothesized population parameter. In a hypothesis test, the probability of obtaining a value of a test statistic equal to or even more extreme than the value observed, given that the null hypothesis is true, is referred to as what? I've already given an MCQ on this, so the option would be clear. The test value of the test statistic equal to or even more extreme than the value, that is the p-value, when the null hypothesis is true and is referred to as the p-value. So here are the key, here are the references, and thank you.
Okay, thank you very much, Dr. Amber. Very nice presentation. However, there are few points that I want to clear. In your first slide of MCQ, please go to the first slide. Right, the second one, please. Okay. In this, you can see that the options are very long, especially the correct option, that was the D option. It is standing out from the rest of the option. So the all the options should be dear to each other, and they should not be very long, so that it is difficult for the reader to understand within 1 minute what is being written there. And to answer it, it is quite difficult. Similarly, please go to your MCQ number 7, please. Okay. Here you have asked about the non-response rates. You in your whole of the presentation, you have not talked about the non-response rates. Am I right, Dr. Amber?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Your presentation was not addressing this MCQ. So the MCQs should be from the presentation, number first. Number second, non-response rate, it is very important whenever we talk about research. And during our synopsis or research, writing a research protocol, we usually define the non-response rate as 5% or 10%. Usually it is not up to 90%. As you have shown in this MCQ, the non-response is 90%. It is invalid research. It is not the non-response rate actually. The non-response rate has to be defined by the researcher depending upon the sensitivity of the issue. Why this is important? Let me tell you. Number first thing is, whenever you are talking about the non-response rate and the question is very sensitive, even the 5% non-response can lead to the inaccurate results or can lead to the bias. For example, let's speak about certain important diseases that have stigma in our society, like ectopic pregnancies in young females, right? Or HIV in children as well as in females. Again, in all these three types of studies, if people are not giving the answers about their stigmatization and they are avoiding this question, our responses would mainly be focused on those who are not having the issue of stigmatization, who are not being the victim of having the discriminatory treatment while they were having a disease. Let's suppose it is HIV. And all those people in our study group who are avoiding to give us the answer, perhaps they are the victim of discrimination and stigmatization. And all those who are coming up with the lot of answers to our questions or who are filling our questionnaire, if they are more than willing to answer our questions, they may not be the right person who have suffered from the victimization or discrimination. Similarly, in violence, in certain other conditions where people, they hide from the scene or they don't want to disclose what is happening with them, they may not be the correct response rate that we are getting from the responders. So even the non-response rate of 5%, that is not acceptable, right? However,
Okay,
in
ma'am.
certain, like for example, diabetes, hypertension, ischemic heart disease, uh, risk factors like smoking, etc., people may answer it rightly, and the non-response rate may not go even beyond 10%. So usually we take it up to 10% if the disease is not causing any discrimination or psychological stress or any social psychological uh, discrimination, etc. However, if the question in hand is very sensitive one, like drug abuse, HIV, sexually transmitted diseases, toxoplasmosis, chlamydia, gonorrhea, syphilis, etc., even the non-response of 5% can lead to a bias in our result. That is why we are not having the non-response in our studies. So today we have not touched this important topic of non-response rate. In some other presentation, we would have a complete presentation on how the non-response would lead to a bias in our results, how to control that bias, and how to design a study that is having the minimum non-response rates. So the 90%
Okay,
non-response
ma'am.
rate, this MCQ I will not go for this MCQ because 90% is too much. It should not be beyond 10%.
Okay, ma'am. I shall change it. Replace
Right.
it.
Please do these corrections. In slide number 2, you have to make
Ma'am.
the correct option homogeneous with the rest of the options. And here in 7, you have to correct it because 90% is too much. It would cause a lot of bias and it is not acceptable in any case. It can be between 5
Okay,
to
ma'am.
10%, depending upon the scenario that you are presenting. You have not presented any scenario. And even this
Yes, ma'am.
question is not related to your topic.
Okay, ma'am.
Right. So we can stop here. If anybody has any question or feedback, you are most welcome to please give the feedback. You can even write in the chat box. You can email us or write in the postgraduate WhatsApp group, or you can even, if you want not to disclose your identity about the feedback, you can even email me on my email address. Thank you very much. Overall, it is a very good presentation. Well done, Dr. Amber. Keep it up. Thank you very much. Allah Hafiz.
Allah Hafiz.